Today's video is about the distributive, associative, and commutative properties. All of these properties will help you with your mental math. The distributive property, as demonstrated below, shows that multiplying a number, x, times the sum of y and z is the same as multiplying that same number, x, times y, and then adding that product to x times z. Using numbers, the same thing could happen for mental math. If I needed to multiply 6 times 23, in my head I know 6 times 20 is 120, and 6 times 3 is 18. I can add those together to get the answer of 138. By taking it into those easier to digest pieces, you can solve larger sum or larger products by using the distributive property. Most people, when they write the distributive property, they show it in parentheses like you can see here and here. But I'd like to point out that if you follow the standard order of operations, 6 times 20 plus 6 times 3, you would normally multiply before you'd add anyway. The associative property is also known as the grouping property. You'll notice that the expression is the same on both sides of the equal sign, x plus 4 plus 3, x plus 4 plus 3. But in the left example, we've chosen to add the x and the 4 first, and in the right example, we've chosen to add the 4 and the 3 first. You can see that under normal circumstances, if your expression was x plus 4 plus 3, you would go from left to right following the standard order of operations. But the associative property gives you the right or the opportunity to choose to add those constants together and simplify your expression as x plus 7. So that way this part is complete and there's only one step once you have the value of the x. The commutative property is also known as the order property, which makes sense because all you're doing is switching the order of your numbers. I think everyone knows that 45 plus 800 is the same as 800 plus 45, because if I told you that you had $45 and then won an $800 prize, very few people would do 45 plus 800. The standard algorithm, most people would put the larger number first, and that's because you guys have known the commutative property since you were very small. And so it's very clear that that commutative property allows you to calculate your sums easier, either in your head or when you write out the algorithm. So to identify which property is which, I have some examples here. And let's take a look at this first example. 5 times p is equal to p times 5. This shows the commutative property. In this example, 4 times x times 10 is equal to 4 times x times 10. You'll notice that they're the same numbers, they've just been grouped differently. This is the grouping property known as the associative property. In this case, 15 plus m is equal to m plus 15. You'll notice it's another example of the commutative property. The commutative property can be used with either multiplication or addition. It cannot be used for subtraction or division. 2 plus 12 plus r, 2 plus 12 plus r. You'll see the order didn't change. It was just the way that the numbers were grouped. This problem would be easier to solve by grouping the two constants together and then add the variable. 3 times the sum of 10 plus 7 is equal to 3 times 10 plus 3 times 7. That's the distributive property. Now, a lot of students have learned how to identify the distributive property by just looking at parentheses. That's not a good strategy. It's more important for you to recognize that 3 times 17 is the same as 3 times 10 and 3 times 7. So we want to make sure we're aware of that. And that's evidenced right here. You can see 2 times the sum of x and 5. You can't really solve this using the standard algebraic order of operations. However, if you apply the distributive property and you multiply the 2 times the x and the 2 times the 5, it could be simplified to 2x plus 10, leaving you with just 2 terms to work with. So that's another example of the distributive property. When you're asked to simplify the expression, what that means is to combine like terms and to use your commutative and associative properties to make the problem as simple as possible. So as few terms as possible. We have a constant here and a constant here. So what we're going to do is actually use our commutative property and change the order of the x and the 1.7. And that way we can then do that first. 7.3 plus 1.7 is 9. 9 plus x would be the simplest form for this expression. In this case, we're told that we should do the 12 plus x first because it's in parentheses. But because it's strictly addends here, we can apply the associative property, which says we can rewrite the expression and group it in another way. And that's what we're going to do. We're going to group our addends and get 19 plus x. Keep in mind the associative property and commutative property work for multiplication or addition. Here's an example of the distributive property. Now, in order to simplify this expression, you're going to multiply the 6 times each term inside parentheses. So 6 times x would be the coefficient 6x. And 6 times 4 is 24. You'll note, because you have a coefficient and a constant, these numbers cannot be added to each other. The coefficient tells you that you got 6 x's. The 24 is just a regular old 24. So that constant cannot be combined with the 6, because then you'd think that you'd have 30 x's, which you do not. In this case, to simplify the expression, we've got some coefficients and some constants that need to be combined. The coefficients go together, 10x minus 3x. You're going to use the sign that precedes the coefficient there to determine whether you're adding or subtracting. So 10x minus 3x would be 7x. And then we're going to add 5 plus 25. So the simplest form of this expression will be 7x plus 30. Here's a word problem that uses the distributive property. Jill is selling handmade scarves at a craft fair. Each scarf costs X dollars to make, and she sells them for $10. Use the distributive property to write and simplify an expression to find the profit earned by selling 8 scarves. So we know that in order to find out how much money Jill would make, or profit, we would have to subtract $10 minus X. But that would happen every single time she made and sold a scarf. Since she sold 8 scarves, we need to multiply 8 times both the 10 and the X, because both things would happen. She'd have to make it and she'd have to sell it. So this is an ideal opportunity to use the distributive property to show 8 times selling the scarf for $10 and making a scarf. And now we can simplify this expression and multiply the 8 times each term inside the parentheses. 8 times 10 is 80, and 8 times x is 8x. Keep in mind the preceding symbol also is used here. So the most simple expression we could use for this is 80 minus 8x. The piece of information we would need in order to solve this expression is how much money that it cost Jill to make a scarf. So you could substitute any value you'd like for the value of x, as long as it was less than 10, because it wouldn't make sense for Jill to sell scarves for less money than it cost for her to make them. Thanks for sticking around until the end. Good luck on your homework.